Let us look at proposition number 12 of book 12 of Euclid's Elements. The proposition says similar cones and cylinders are to one another in triplicate ratio of the diameters of their bases. So let's see how we can prove this. So let there be similar cones and cylinders such that circles ABCD and EFGH are their bases. BD and FH are their diameters. KL and MN are their axes. Now, purposely I have not shown the cylinders. Since cylinders are 3 times the cones, that part would be pretty straightforward. So let's take care of the cones first. So what the proposition is saying is that cone ABCDL is to cone EFGHN is equal to the triplicate ratio of BD is to FH. That is the diameters. And it also says that cylinder on ABCD is to cylinder on EFGH is equal to the triplicate ratio of the diameters of the bases. Let's use proof by contradiction. Let's say cone ABCDL is to cone EFGHN is not equal to the triplicate ratio. Which means what? That there must be a solid which is less than the cone EFGHN or greater, which will make this proportionality true. So let's take it one by one. Let cone ABCDL is to solid O, which is less than cone EFGHN, is equal to BD cube is to FH cube. Now, inscribe the square EFGH in the circle EFGH. Now, the points I have chosen in such a way that they actually form a square to avoid, lot many points. So let's draw the square, which means square EFGH is greater than half of the circle EFGH. Set up on the square EFGH a pyramid with the same vertex as the cone. Pyramid is greater than half of the cone. We bisect the circumferences EF, FG, GH and HE, and we join those points to form a polygon. Now, if you look at this, each of the triangles EPF, FQG, GRH and HSE, they are all going to be greater than half of that segment of the circle which is about it. Now, on these triangles, we set up a pyramid with the same vertex as the cone. Now, each of these pyramids, E, P, F, N, F, Q, G, N, G, H, R, N, and H, S, E, N, they are all going to be greater than half of the segment of the cone about it. Now we keep repeating this process of bisecting and building the pyramids so that at some point there will be some segment of the cone which is less than the difference between cone EFGHN and the solid O. Again, to avoid complicating the diagram, let's say we have reached that state. So the pyramid on this polygon EPFQGRHS is greater than solid O. We inscribe similar and similarly placed polygon in the circle ABCD. Similar and similar to which one? This polygon to the circle ABCD. So we build a polygon and let's build a pyramid on that, which is what the next step says. Set up a pyramid on this polygon. BD, which is the diameter of the circle, is to FH, which is the diameter of this circle, is equal to KL is to MN. the axes of the cones are proportional to the diameters, since the cones are similar. Now we also know that BD is to FH equal to BK is to FM. BD is to FH as BK is to FM. Pretty straightforward, right? This is the diameter, BK is the radius, FH is the diameter, and FM is the radius. So since diameter is just a multiple of the radius, we can say BD is to FH equal to BK is to FM. Now here we have BD is to FH, here also we have BD is to FH. So which means BK is to FM is equal to KL is to MN. Alternately, we can say BK is to KL is equal to FM is to MN. BK is this, KL is the axis, FM is the radius, and MN is the axis. Now to make the diagram clearer, let me hide these pyramids. So here BK is to KL is equal to FM is to MN, which means triangle BKL is similar to FMN. Why? Because angle BKL is a right angle. Similarly, FMN is a right angle. And the sides about this equal angle is in proportion. So we can say these triangles are similar. PK is to KL is equal to PM is to MN. PK is to KL as PM is to MN. So triangle LKT is similar to NMP. Why? Because again the angles TKL and PMN are both right angles, and the sides above them are proportional. LB is to BK is equal to NF is to FM. LB is to BK is equal to NF is to FM, since these two triangles are similar. Now BK is to BT is equal to FM is to FP. Since triangle BKT is similar to triangle FMP. So here we have LB is to BK is to BT is equal to NF is to FM is to FP. So X equally, we can say LB is to BT is equal to NF is to FP. Now LT is to TK is equal to NP is to PM. Since triangle LTK is similar to triangle NPM. Now TK is to TB. TK is to TB is equal to PM is to PF. Since triangle TKB is similar to PMF. X equally LT is to BT, because we have LT is to TK is to TB. NP is to PM is to PF. So we can say X equally LT is to BT is equal to NP is to PF. LB is to BT is to LT, or we can write it as LT is to BT is to LB is equal to, again NF is common, so we can say LT is to BL is equal to NP is to NF. That means triangle LTB is similar to NPM. F. By doing all this, what have we achieved? Remember, this solid can be treated as a pyramid. So pyramid BKTL is going to be similar to pyramid FMPN. Why? Because these two pyramids are contained by similar planes. So pyramids are similar. And we know that pyramid BKTL is to pyramid FMPN is in triplicate ratio of the bases. And bases are BK and FM. But this is just the radii of the circles. So which means since the diameter is just a multiple of this radii, so we can say it is pyramid BKTL is to pyramid FMPN is equal to the triplicate ratio of the diameters of these two circles. Similarly arranged pyramid is to pyramid. We can build around the circle all the remaining pyramids. So those similarly arranged pyramid is to pyramid is equal to corresponding radius cube is to corresponding radius cube, which is equal to BD cube is to FH cube. And pyramid BKTL is to pyramid FMPN is equal to the pyramid on the polygon ATBUCVDW is to pyramid on this polygon, that is EPFQGRHS. That means pyramid on ATBUCVDW is to pyramid on EPFQGRHS is equal to the triplicate ratio of the diameters of the bases. Now, remember we started off by saying cone ABCDL is to solid O is equal to BD cube is to FH cube. And here also we have BD cube is to FH cube. So that means cone ABCDL is to solid O is equal to pyramid on ATBU CBDW is to pyramid on EPFQGRHS. And alternately, we can say cone ABCDL is to pyramid on ATBU CBDW is equal to solid O is to pyramid on EPFQGRHS. Since cone ABCDL is greater than pyramid on ATBU CBDW, why? Because cone contains the pyramid or encloses the pyramid. That means solid O is also greater than pyramid EPFQGRHS. So we have solid O is greater than pyramid on EPFQGRHS since cone ABCDL is greater than pyramid ATBU CVDW, which is a contradiction. Because you see here we have a statement the pyramid on EPFQGRHS is greater than solid O. And here we are ending up with solid O is greater than pyramid on EPFQGRHS. So because of this contradiction, solid O cannot be less than cone EFGHL. So this was our case 1, where solid O was less than cone EFGHL. Now let's look at the other case where it is greater. Let cone ABCDL is to solid O, which is greater than cone EFGHN, is equal to the triplicate ratio of the diameter of the bases. So now we can inversely write it as solid O is to cone ABCDL is equal to FH cube is to BD cube. Solid O is to cone ABCDL is equal to cone EFGHN is to some solid less than cone ABCDL. So basically the second case, we are converting it in such a way that we end up with case 1. So cone EFGHN is to some solid less than cone ABCDL is equal to FH cube is to BD cube. which we have already seen in the previous case that it is impossible. So therefore, cone ABCDL is to cone EFGHN is equal to the triplicate ratio of the diameter of the bases. Since it is neither, it can be neither less nor greater. When bases are similar and heights are equal, we know cylinder is to cylinder is equal to cone is to cone. Since cylinder is nothing but 3 times the cone. So let me bring in the cylinders just for visual impact. Cylinder on ABCD is to cylinder on EFGH is equal to the triplicate ratio of the diameter of the bases, which is what we had to do. So that was proposition number 12 of book 12 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.